So we have completed the first session, so we're into a question and answer period. So please go ahead and type your questions from any of the previous speakers into the chat, and we'll bring a speaker online to address those questions.
I found this one chat. What is the expected recharge capability via what means? So is this maybe Sato-san, can you answer this question? Please read the chat from the All-san.
Yeah. Okay. So recharge capability, I think the question is to the about the power generation capability. So it's going to be a 10 kilowatt of the solar array capability, and what was the next question? Sorry, what was the kind of question?
Okay. Oh, there are a lot of chats, so Ryan, how to manage the chat? So can you pick up a couple of the questions?
I think the next question was, what's the notional CONOPS for crew ingress and egress?
So we have the actual steps on at the rear side. So the first during the ingress, the approach to the pressurized rover, and the first the crew needs to unfold the step and up the deck. Then the crew climb up to the after deck using the step. Then so before that, the cabin should be depressed, and then crew open the hatch and ingress to the pressurized rover cabin. So that is the very high level concept of the ingress, and depressed operation is the opposite way. So once the crew wear the egress suit, then the cabin will be depressurized. Then crew open the hatch, then go to the go outside. That is high level concept. I'm not sure this explanation is enough or not, but
Thank you. So let's see, the questions keep coming. Question, is there any thermal control for payloads? How much heat can internal payloads generate?
I believe this is talking about internal payloads. But, for the internal payloads, currently our capability to take several hundred watts in total, not for each, but in total. So, and for the external payload, we don't have any active thermal control capability. So each payload should have the heat dissipation capability for its own.
Okay, yeah, so just a read back, there's a couple hundred watts capability for the internal, but the payloads should have some cooling capability for themselves. Is that correct?
Yes.
Thank you. Let's see. Yeah, question, couple PSR questions related. So will the pressurized rover be able to access the PSR, and would there be any special heating needed for the pressurized rover? So it's Sato-san again.
Sorry. Please repeat your question.
Will the pressurized rover be able to access a permanently shadowed region?
Oh. So for the very short duration, we can go the very low temperature area. I'm not sure if this is a permanent shadow area or not, but we have some requirement to go to the very low temperature area for the limited duration.
Okay, yeah, thank you.
The next one, are there the external cameras on the rover for navigation and or surface observation? And this is the next question for Sato-san. Again,
Yes,
please.
yes, we have several cameras, but basically this is for the pressurized rover operation.
So, and the next one is will the pressure rover has spare parts in the case of the robot arm failure or other anomaly?
We will have some spares for very critical parts. But basically, we have one failure tolerance capability embedded in the pressurized rover.
Thank you. Oh, and give the constraint on the battery and recharge. What is the maximum distance that we should expect for the pressure rover? How far can we get from the charge? Also, same to the Sato-san. Yeah, please.
I believe that this is question about how distance can travel within one charge, right? So in this case, it's about 18 kilometers for one charge.
And next one is how is the logistic lander utilized during the crewed and uncrewed mission timeline? Who can answer it? Also, same as Sato-san by Sato-san or
So how
is the logistic lander utilized during the crewed and uncrewed mission timeline?
I think some of these, if we can ask the audience to please keep the questions for science focused and utilization related to payloads and such. We won't be able to answer a lot of the larger architecture questions at this point. So maybe that we can move on to another one that's payload related.
So basically, the logistic lander will bring the food and payload. So right after the crew landing, we retrieve those food, water, and payload from logistic lander for 2 weeks. And then after 2 weeks exploration, we'll go back to the logistic lander and then exchange the logistics or payloads if needed. So that is the overall concept to use the logistic lander. I hope this helps the answer of the question.
All right. Next one is, what is the maximum expected power draw during traverse, and what is the estimated energy storage capacity of the battery and fuel cells?
So I think maybe if I can jump in, I think maybe this is another one that we will pass on answering at this time, and just to keep the focus on some on science, if that's
Yes, sure.
okay with JAXA.
Okay.
Maybe we ask, there's one Inatomi-san about how payloads are brought into the pressurized volume. We could talk to. I think this is getting at, if a payload is brought to the surface, how do we get the payload into the cabin if it's an internally mounted payload? Crew installation, I think, is what we've talked. I see another question on cameras and sensors, science related. Could
for
JAXA comment
example,
on that?
So
Sato-san, do you have any words or comments around the what sensors might be available for navigation, science navigation, I guess, science operations?
So again, we have several cameras for the Pressurized Rover operation, and you can use that camera data as much as possible for science also. And we have a LiDAR, but it's also for the Pressurized Rover traversing operation, that you can use that data. But it's just the LiDAR data is just kind of the log distribution or something like that. So I'm not sure if it's so beneficial for the science data, but still you can use. And we have several acceleration or IMU data, but I'm not sure. That's all, maybe.
Yeah, thank you.
Also, we have, this is not decided yet, but we may have some ground penetration radar system for the traversing to look at the rocks on the ground or under the under the surface. So if we have the capability, you can use that data from the radar.
Thank you. I see when the total electrical power available for payloads, the one we could talk to.
So again, it will be several hundred watts for the payload in total. So it's internal and external. So but we are now coordinating with NASA about what is the most appropriate power allocation for payload.
Yeah, thank you. Yeah, several hundred watts. So it's more to be worked on that.
So I found one question. So, is there any plan to invite other scientific instruments from other nations? Just a possibility. Do you have any idea or?
Is the question talking about time
Yeah.
or Pressurized Rover?
Yeah, from the Hojin-san. So, yes.
I think it depends on the how the science on the Pressurized Rover is programmatically framework. So it should be coordinated first between NASA and JAXA, but you can expand that science opportunity to other nations. But from our side, we cannot say so detailed.
Thank you.
See one commenting about the external payload mounted, where those payloads would go, and I think the slide Sato-san provided showed where the planned payload locations are. So I'll refer that question to those slides. Question around PR operating during lunar nights, I think periods of extended darkness, and then maybe what challenges in low lighting and low temperature environments. So I guess Sato-san, could you remind how much time the pressurized rover can spend in periods of extended darkness, crewed and uncrewed?
So for crewed is 36 hours, and for uncrewed is 192 in phase 1. But for phase 2, in uncrewed mode, you can survive the 14.5 days.
Okay, thank you.